You might hear these called, they're Markov matrices, you might hear them called Markov processes, or Markov, chains. I'm going to switch to a new pen for more ink. A Markov matrix models transitions step by step by step by step. Markov matrices, Markov processes, Markov chains, different names for the same thing. So, for example, suppose I have two major political parties. This doesn't sound like Australia at all. E.g., suppose I have two political parties. What do I want to call my political parties? A and B? Or do you want to use the textbooks? Progressive and conservative?
A and B.
A and B? Okay. A and B. At the last election, each won 50% of the vote. I don't know why I'm skipping capitals, I better fix that. Of the vote. That is very messy, Mr. BM. Of the vote. Of the vote of the votes. That'll be. Okay. It's known that if someone in this area voted for A, it is 90% likely they'll vote for A next time. And if someone voted for B, it's 85%. Wow, that's a lot. They're pretty conservative. Likely they'll vote for B again next time. Wow, my writing is really messy this afternoon. That was supposed to be vote. So this is the kind of information you'll get for a Markov process. Given you're in this state, what's the chance of going to this state or the other state next? Okay, so what I'm going to do is make a matrix. Let's make a transition matrix. I'm going to use the same kind of matrix multiplication we have done many times already. T is going to be A, B, A, B, and we've got to get our rows and columns right. And we're going to go from, I like that horizontally, I don't have to write sideways, and 2. So if they did vote for A, there's a 90% chance they'll still vote for A. And if they did vote for B, there's an 85% chance they'll still vote for B. What numbers do I have to put in the other two spots?
1 minus.
Yeah, 1 minus which one?
number.
90% chance from A, so there's another 10% who are going to B. 85% from B to B, so there's a 15% chance of them going to A. Each column has to add to 1. Hint, I can feel a multiple choice question coming along saying, which of these is a valid Markov matrix? One of the things you should check is each column adds to 1. And again, if you look in old books or online, you might see people doing from and to swapped, and all the operations are swapped in order. Exactly the same. Okay, first question. After the next election, what's the proportion of votes going to be? After next election, what proportion of votes will each party get? So what I'm going to do is I'm going to start with an initial state, S for state. That's what I know I'm starting with. 0.5, 0.5, half each. And then if I'm going to go to the next election, I'm going to go T times S naught. How is this going to work? 0.9, 0.15, 0.1, 0.85 times half, half. How does that work? Half of these 50% and 15% of these 50% are going to vote for A in the next election. 0.1 of this 50% and 85% of this 50% are going to vote for B in the next election. So the matrix multiplication is doing that for us. You're allowed to use a calculator because they're horrible decimals.
S is the first election, S one is the second. Is capital S like
state? S for state. Because these are actually modelling progressive, one state, then the next state, then the next state, then the next state. Initial state. And what do we get?
$525 and $475.
So in the next election, A got 52.5% and B got 47.5%. And this looks just like the Leslie matrix. You right, Olivia, over there?
Yeah.
Okay. So if I wanted to go what happens after one after that, I could go T times S1. But wait a minute, that's the same as T times S naught, which is T squared S naught. And so on and so forth. So here's the question. If we keep having elections on and on and on and on, what's going to happen?
You mean at the very end?
Yeah.
100%.
So what happens? It's not going to be quiet because every time there's an election, some people go back to voting for the other party.
Equilibrium.
So yes, it's called equilibrium. So work out for me, what's S100? Get your calculator and ask it for that.
0.6, 0.4.
And I bet if you change this to 200, nothing's going to change.
No.
This is called steady state. Why? Because it's a state matrix that doesn't change. Frankly, if the question asks you for the steady state one way or another, put in a big number, it'll probably work. But it would be nice if there was an algebraic way to get there, wouldn't it?
Guess and check.
Yeah, this is what this is, right?
That's what I just did.
But there is algebra. What I'm asking for is a matrix here, a state matrix, that when I multiply by my transition matrix, it doesn't change. To get the steady state, I want S equals TS, right? Eddie, what we just looked at, you put a 1 here,
Okay.
it's actually an eigenvector. They turn up in all kinds of interesting places. Okay, what does this mean? That means I want to go, oops, give me a bit longer, X, Y has to be up there, 0.9, 0.15, 0.1, 0.85, X, Y. Solve for X and Y. How do I solve for X and Y? Pick one of about 7 methods. Will it help if I write you an equation? X equals 0.9x plus 0.15y, and y equals 0.1x plus 0.85y. Can you solve those equations? Yes, you can. 2 linear equations with 2 unknowns. But you need a little bit more information. A little bit more information you need is, what do these two numbers have to add up to?
Wouldn't it be 1?
X plus y equals 1. Okay, now we can solve by going, y is 1 minus x. Plug it in. X equals 0.9x plus 0.15, 1 minus x. X equals 0.9x. Let's move them all to one side. 0 equals 0.9x plus 0.15 minus 0.15x minus x. This on this side, negative 0.15 is 0.9, negative 0.1, negative 0.25x. Same answer. Therefore, y has to equal 0.4. So if you need to find steady state, you have 2 options. If you've got a calculator, you can just put a big number in here. That will work. Or if you need to show algebraically, then solve this equation using this. If you've got X, Y, and Z, because it's 3-dimensional, it's going to be harder.